So in our last video, we got to the point where we figured out where you know, A1, B1, and C1 are going to be. So we at least have a picture of what the triangle is supposed to look like, but we still need to figure out how these calculations work. So here's, and again in this video, just like in the last one, I'm just going to be looking at the refactored version of the program, the one where I have the triangles and CV triangles classes split into two different files. So we're not looking at the book version, although some of the, you know, you'll recognize this code from the book version too. But what we have here is this bit where we're calculating the subsequent vertices. What point A1 is going to be XA1 comma YA1. Okay, that vertex, and then, you know, the next vertex is going to be XB1 YB1. Okay, so we have this general formula here for XA1 that equals P times XA plus Q times XB. Okay, and it's, you know, a very similar kind of formula all the way through. So let's take a closer look at that. So first of all, for Q, we saw that what we do is we pass that in. So in the original version, and I'm in NetBeans now with the original refactored version, we have, you know, 0.05. So we're just scooching over the triangle just a tiny bit, and but notice, so Q is the 0.05 that gets passed in, and then P is going to be 1 minus 0.05, or in the original version is 0.95. Okay, so and let me just run the original version actually for a second here, if I haven't messed it up. Let's see. Oh yeah, I changed it to 2. Well, that's all right. We can look at the 2 version. So in this version, we just scooched over, you know, 1/20th, or 0.05. Our Q is 0.05, and our P is this 0.95, right? So it's P times XA plus Q times XB. All right, so I think one way to get some more insight into this, so one thing we did before was, you know, we changed it to, and I'm going to flip over to the Eclipse version now. One thing we did was we changed it to be 0.25, and we saw when we did that, it scooched things over even more, right? So now we're scooched over 1/4 of a side length here, and this is 3/4. So Q is 1/4, or 0.25, and P is 0.75, right? So P is 1 minus Q. Okay. Let's do this. Let's scooch this all the way over to be just 0.5, to be half, and see what that looks like. And before I even run this, take a second and think about this. What do you think this guy's going to look at? You might even want to pause the video and think, or it might just occur to you right now. But I'm gonna go ahead and run this. You can pause the video if you want to. But let me see. If I run this, we say run as yoink, and there it is. Look at that. So what happens? Well, we have, here's our A1 and our B1, but look at, we're going to midpoints. Let's look at it with some annotation here. So we're actually, what are we doing? We're saying A1 is exactly in between A and B. B1 is exactly between B and C. And C1 is exactly between C and A, right? So we're actually, when Q is 0.5, we're actually connecting the midpoints. So let's substitute in. So if Q is 0.5 and P is 1 minus Q, then P is also going to be 0.5, right? So P and Q are both 0.5, so we can actually do some substituting in. So here's the original statement to calculate XA1 from the Java code, and I rewrote things a little bit over here because some people might be more comfortable with the algebraic way of writing things, right? So I have x sub A1 equals P times x sub A plus Q times x sub B, right? Now I'm substituting in. So I have I know P is 0.5 and Q is 0.5. So I'm saying XA1 equals 0.5 F. Remember that F just tells me this is a float. So 0.5 F times XA plus 0.5 F times XB. And 0.5 we know is 1/2. So right, so this is the same as saying x sub A1 equals 1/2 x sub A plus 1/2 x sub B. And then we can simplify that further by saying XA1 equals the quantity XA plus XB over 2, right? Which it might be easier to see over here. 1/2 XA plus 1/2 XB is the same as it's the same as XA plus XB over 2, right? Now this might be familiar to some of you. This is the midpoint formula for the x coordinate, and for the y coordinate similarly we would say y YA plus YB over 2. Okay, so you can see that when P and Q are both 1/2, that this formula works out to be the midpoint formula, which is probably known to most of you. So that's kind of a way of saying, well, yeah, this kind of makes sense, at least for the case where P equals Q. And then what we'll do is in subsequent videos we'll try and generalize this a little bit and see how this formula or this one with when P and Q are not equal but they add up to 1, how that one in general works.